Okay, so in this video, this time, it's going to be about logarithms and in particular, how to solve logarithmic equations. What I have written here is just your basic way to rearrange a logarithm. And what I want to point out first is that the best way to sort of remember this is to say to yourself that the log is equal to the index. If you memorize that and you're starting with, say, an indice equation like this is the index here, x. And if you remember that the log is equal to the index, then that means this log must be equal to this x. The second thing to remember is that the base number obviously should always be the bottom number of that index, because that's what a base number is. It's the base, it's the bottom. That is going to be the same thing for a logarithm. It's going to be the base of the logarithm. So once we know where the index is, x, and it's going to be equal to here, we definitely know where the base is, a, and then there's only one more aspect left of the equation, and that is y. So the solution, or the letter of y, should go inside the logarithm there. So log to the base a of y is equal to x. That's equivalent to a to the power of x is equal to y. So we'll just do a few problems rearranging this and being able to solve these logarithmic equations. Here's an example. Log to the base x of 8 is equal to 3. Again, tell yourself the log is equal to the index, or the power. So if this log is equal to 3, then that means 3 must be the power, which it is here. So as soon as we've got that right, we've got something to the power of 3, and the base number is always going to be underneath that power. The base number of the logarithm is x, so it should be x to the power of 3. There's only one number left, and that's 8. So it must be x to the power of 3 is equal to 8. And if you've got a friendly equation like this, you can figure it out in your head and say, okay, what number do I need to multiply 3 times together to get a solution of 8? And that number will be 2. 2 times 2 is 4, times 2 is 8. 3 times. So 2 is the solution. And when we've got logarithms, we could be asked to solve for any part of an index equation or any part of a logarithmic equation. The x could be the base number, the x could be here, the x could be here. Who knows? But the point is we can rearrange it in any way and find the solution if we understand how to flip between logarithms and index equations. So let's look at this problem. I also encourage you to maybe pause the video for just a minute or two and see if you can actually solve this before I do it. But I'll start doing this right now. We'll just rearrange it first, and we'll go through that same process that I explained before. Now, the log, I'll start with the base number. This is log to the base of x. So I'm going to write the base number first. X is the base number. The logarithm is equal to the power. So this is equal to -2. That means -2 must be the power. So I'll write -2 there as the power. There's only one thing left over, and that's 1 over 64. So this must go here, 1 over 64. And now we've got to do our best to try and simplify this and to find what the solution is. So x to the power of -2, if we flip that upside down, this is going to be 1 over x squared. And that's just another property of indices, 1 over x squared. The negative becomes a positive when we put it on the bottom. We won't change anything yet here. That's 1 over 64. But because both sides of this equation are 1 over, we can simply restate the equation like this. X squared is equal to 64. And then can we figure this out in our head? Ask yourself that as well. What number do I need to square to get a solution of 64? Okay, what number is that? 8 times 8 is 64. So x will be equal to 8. Now, an alternative use for logarithms. This will always work as well. If we have, say, an equation like this, 8 to the power of x is equal to 90. We've got a base number of 8. And if we don't want to write log to the base 8, and we want to use a base number like log to the base 10, which is a bit more manageable sometimes if you're trying to solve on a calculator, we can simply just take the logarithm of both sides of this equation. So we can go log to the base 10 of 8 to the x and log to the base 10 of 90. From here, we can simply take the x out to the front of the logarithm. So that's another logarithmic property. When you've got a power inside the brackets there, you can take that power out to the front of the logarithm. And we really just have an algebraic equation here. So I can get this x by itself by dividing through by log to the base 10 of 8. And that gives me log to the base 10 of 90 divided by log to the base 10 of 8. And if you put that into your calculator, you get a number 2.164 if we round to 3 decimal places. So the issue, this is a good alternative to use when you might, if you're going to use your calculator, you can't necessarily sometimes, depending on the calculator you use, might not be able to change the base number. Maybe it only has log to the base 10 or log to the base e. So you can always take the logarithms of both sides of the equation and solve exactly like this. Now, what I've really done here is just a longer method of this particular formula. And this particular formula is called the change of base formula. If I have a log with a base number that I don't particularly like or might be too difficult to work with, I can change that base number to whatever I like, exactly like what I did in the last problem. But we can skip a few steps and just go directly to this formula here, okay? So whatever the base number is, in this case, I'm saying it's A, will be the what we take the log of on the bottom part of this fraction. Whatever the x is, or whatever is inside here, the x, will be on the top part of this fraction. And it's up to you what base number you put. You would probably choose log to the base 10 or log to the base e, because calculators will always have those values to choose from. If we apply this directly to the last problem that I just had on the screen, and I've got 2 different alternatives here. X is equal log to the base 8 of 90. So I've written it as a logarithm, but I want to change the base. That's what I've done here. So I just choose the base number I want, 10 in this case, and it'll be log to the base 10 of 90 divided by log to the base 10 of 8. Choose another base number. This would be log to the base e. Remember that ln is a different way of writing log to the base e. So again, log to the base e of 90 divided by log to the base e of 8. Whatever you choose, you get the same answer as before, 2.164 if we round to 3 decimal places. So this is always an option. You can always just take the logarithm of both sides of an equation, or just change the base number and use your calculator accordingly, if that's the case. Okay. This is a good example because the base number here is a half. So it's not even a whole number. So if we're going to use the change of base formula for this, we first need to write it as a logarithm so it looks a bit more familiar in terms of the logs. So the base number is a half. I will write log to the base of a half of 15 will be equal to x. It's what I said before. The log is equal to the power. So the log must be equal to x. The base number is a half. So it'll be log to the base of a half. Only number left over is 15. So this is how we can express it in this way. Now, let's change the base number so we can deal with it a little bit better. Okay, so I'll rearrange it and say x is equal to log to the base of 10. Let's use that one. 15 is I like to think of it, it's the higher number. So it will be log to the base of 15 will be the top fraction. And then the bottom fraction will be log to the base of 10 of a half, like that. And using your calculator, you can type that directly in. And that number, if you round to 3 decimal places, comes out to negative 3.907. So something like this, you would not be able to work that out in your head. You wouldn't be able to guess that number. It's not part of your basic times tables, negative 3.907. But nevertheless can be easily solved if we use the change of base formula. After we know how to, of course, write things as a logarithm, to go from an index equation to a logarithmic equation and vice versa. So that's it for this video. The purpose was to just show a few examples on how to rearrange from an index to a log and back again. And then, of course, how to solve these equations by changing the base of a logarithm and making it a bit more manageable to use in a calculator if your calculator does not have an option to type in base half, for example. So that's it for this video. Thank you very much for watching, and see you later.